CIET NCERT presents audiobook Ganit Manjari Part 1, Textbook of Mathematics for Grade 9.
Chapter number 1, Orienting Yourself, the Use of Coordinates. Page number 1. On the right side of the page, you are provided with a QR code, scanning which you can reach out to the additional resources to this chapter. 1.1 Introduction. A system of coordinates is a structured framework like the grid lines on a map or graph paper that enables us to use numbers to describe the exact physical locations of points or objects. The idea of grid-based thinking and the geometry required to define the locations of points in space indeed has deep roots in Bharat. The first systematic use of grids occurred thousands of years ago on a massive urban scale in the Sindhu Saraswati civilization, where city streets were constructed with striking precision in north-south and east-west directions at uniform distances of about 10 meters apart. This was a coordinate system in practice. A merchant could find a shop or a warehouse by counting north-south and east-west units of distance from the city center. Bodhaina, c. 800 CE, as we have seen later, used east-west and north-south lines for his deep geometric constructions, developing the Bodhaina-Pythagoras theorem and thus laying the foundation of coordinate geometry. Putting coordinates on the Earth's surface later became important for navigation. Ujjaini was described in the ancient world at least as early as the 4th century BCE in the early Siddhantas as the point marking the central longitude meridian from which all other locations were measured. The Greek mathematician Ptolemy c. 150 BCE, building on earlier works, including that of Hipparchus, later described the latitudes and longitudes of thousands of locations, including Ozin, Ujjaini. Aryabhatta c. 499 CE replaced the Greek chords with signs, making it much easier to calculate the coordinates of a star or a city. He mapped the sky using celestial coordinates, measuring coordinate distances from the ecliptic, the path of the sun. Brahmagupta c. 628 CE formalized the notion and use of zero and the negative numbers as algebraic entities. In modern coordinate systems, the origin is 0 and the negative axis represent values less than 0. Without Brahmagupta's work, the four-quadrant Cartesian plane, as we will study in this chapter, would be impossible. Page number 2. Brahmagupta's work was translated into Arabic as the Sindh-Hind and the Ujjaini meridian entered Arabic geography under the name Erin, serving as the zero longitude reference for early Arabic maps, which also then made use of negative numbers. The influential Arab scholar Al-Biruni c. 1000 CE traveled to India, studied the Siddhantas and used Indian trigonometric methods to calculate the coordinates of various cities across Asia. Al-Biruni also later perfected the astrolabe, a handheld device that allowed sailors to find their coordinates by looking at the stars. Omar Khayyam, c. 1100 CE, who had become an expert in the Indian decimal system and algebraic formalism, was the first mathematician to solve algebraic problems using geometry by interpreting them in terms of coordinates in the plane. These concepts eventually reached Europe in the 12th century. The final leap occurred when, following the related work of Fermat, 1636 CE, René Descartes, 1637 CE, formalized the fact that any point in a two-dimensional plane could be defined by simply two numbers representing the point's distances from two perpendicular axes. Points and more complex geometric shapes could then be described precisely using algebra and equations, thus bringing the areas of geometry and algebra even closer together. In grades 9 and 10, you will have a chance to study this amazing coordinate system, which has such a rich history in human thought and endeavor. You will be able to locate objects with pinpoint accuracy. You will also see how using coordinate enables us to visualize algebraic equations as geometric shapes and vice versa. We begin our study of coordinates with a story that will help you understand these new terms better. 1.2 Settling in. It is the beginning of the academic year and Rian is both excited and nervous. The family has just moved to a new city. He and his sister Shalini will be attending a new school. Today, Shalini will help him settle into the new environment. When someone is not able to see, this can be a very big challenge. But with their mother's transferable job, the siblings have done it often, and it has become easier with each move. Shalini has just completed grade 9, and this time she decided to put to use what she has learned in coordinate geometry in mathematics to guide Rian. Shalini wanted Rian to feel the directions, so she used a rectangular grid on which she had fixed pins and threads. Page number 3. This showed the floor of the room. Points in the sketch were marked using pins. Shalini was using a scale of 1 centimeter is to 1 foot. She used pins to mark out various key points of the room. Points representing the corners of objects were connected with thick wool so that Rian could feel their positions with his fingers. Here we are provided with a sketch of Rian's room. We can find the positions of the doors, and there is a wardrobe in between the doors of measurement 4 feet by 2 feet. The size of the bedroom is 12 feet by 10 feet. We can also find the bed placed in the room with a table placed aside this, having a lamp over it. Then on the left side we have the bath area in which the bathroom size displayed is 6 feet by 9 feet. Let us examine figure 1.1 to understand the layout of the room. Notice that this only depicts the map of the floor. Do you notice why the position of the windows cannot be marked on this map? 1.3 The 2D Cartesian Coordinate System. In the chapters on integers, rational numbers, and decimals in earlier grades, you studied the number line, which is one-dimensional. The two-dimensional coordinate system uses two lines at right angles to each other to mark points in two-dimensional space. Short form 2D space. For convenience, we consider one of the lines to be horizontal. It is called the x-axis. The other line is vertical. It is called the y-axis. The point of intersection of the x-axis and y-axis is called the origin O. Its coordinates are 0, 0. Inside the brackets, coordinate axis, this is the plural of axis, helps us to locate any point in 2D space using the point's coordinates. Distances from O are marked off in equal units on both the axes. Distances to the right of O or upwards from O are considered positive, and distances to the left of O or downwards from O are considered negative. Figure 1.2. Page number 4. Here we are provided with a figure 1.2 structure of the coordinate plane. In this figure, we find the x-axis displaying the numbers -7 to +7, and on y-axis we can find the markings from 5 to -5 with origin O at the center. And we also have point E marked as -2.9, 0. Origin O is marked as 0, 0. Point B is marked as 4.5, 0. Point H is marked as 0, 4, and point G is marked as 0, -4.5. Point B is on the x-axis and 4.5 units to the right of O. Its coordinates are 4.5, 0. This fact is written as B is equal to 4.5, 0. Point G is on the y-axis and 4.5 units downward from O. Its coordinates are 0, -4.5. That is, G is equal to 0, -4.5. Point H is also on the y-axis but 4 units above O. Its coordinates are 0, 4. That is, H is equal to 0, 4. A point P is equal to x, 0 lies on the x-axis. If x is positive, then P lies to the right of O. If x is negative, P lies to the left of O. A point P is equal to 0, y lies on the y-axis. If y is positive, P lies above O. If y is negative, P lies below O. While writing the coordinates of a point, it is often convenient to drop the equal to sign and write P is equal to x, y simply as P within brackets x, y. This is especially true while marking points on a graph. Exercise set 1.1. Figure 1.3 displays Ryan's room with points O, A, B, C marking its corners. The x and y axes are marked in the figure. Point O is the origin. Page number 5. Here in figure 1.3 we have the positions marked as A, B, C, D of a room. A point is 12, 0, B is 12, 10 and right wall is written along the side AB. Point C is 0, 10 and we have O as 0, 0 along the y-axis. OR represents the x-axis on which we can find the points as +1, +2, +3, +4, +5, +6, +7, +8, +9, +10, +11 and +12. Along y-axis OC, we have the markings as +1, +2, +3, +4, +5, +6, +7, +8, +9, +10. We have some more points marked on y-axis as B1, B2. Along the x-axis, we have the points origin O 0, 0, W1 at 3, W2 at 7, D1 at 8 and R1 at 11.5, 0 and A at 12, 0. We also have coordinates of wardrobe indicated here as W1, W2, W3, W4 and the position of the bed is mentioned with coordinates S1, S2, S3, S4. Referring to figure 1.3, answer the following questions. First one, if D1R1 represents the door to Ryan's room, how far is the door from the left wall, the y-axis of the room? How far is the door from the x-axis? Second, what are the coordinates of D1? Third, if R1 is the point 11.5, 0, how wide is the door? Do you think this is a comfortable width for the room door? If a person in a wheelchair wants to enter the room, will he or she be able to do so easily? Fourth one, if B1 0, 1.5 and B2 0, 4 represent the ends of the bathroom door, is the bathroom door narrower or wider than the room door? Think and reflect. Question number 1. What are the standard widths for a room door? Look around your home and in school. Question number 2. Are the doors in your school suitable for people in wheelchairs? Page number 6. So far, we have only considered points on the two coordinate axes. What can you say about the coordinates of points that are not on either axis? The plane in which the axes are situated is called the Cartesian plane, the coordinate plane, or the xy plane. The axes divide the plane into 4 parts called quadrants. They are numbered as given in figure 1.4. using the conventions that we have stated earlier. First, points in quadrant 1 have both x and y coordinates positive. Second, points in quadrant 2 have negative x coordinate and positive y coordinate. 3. Points in quadrant 3 have both x and y coordinates negative. Fourth, points in quadrant 4 have positive x coordinate and negative y coordinate. Can you now notice the meaning of the coordinates of a point in 2D space? In general, the coordinates of a point P in 2D space are represented by x, y within brackets. Here, x represents the perpendicular distance of P from the y-axis measured along the x-axis, and y is the perpendicular distance of P from the x-axis measured along the y-axis. X is the x-coordinate and y is the y-coordinate of the point x, y. Here we have figure 1.4 in which we can find the x-axis and y-axis both perpendicular to each other and meeting at O origin as 0, 0. Quadrant 1 is marked towards the right side. Quadrant 2 is marked towards the left side, in which we can have a display of the point Q as -5, 3. The quadrant 3 is below quadrant 2, and we have quadrant 4 just below the x-axis where the numbers are marked as positive. There is a point S displayed with coordinates 3, -5. Page number 7. For example, in figure 1.4, point S 3, -5 is in quadrant 4. The x-coordinate is 3 units and the y-coordinate is -5 units. What about point Q? -5, 3. It is in the second quadrant with x-coordinate -5 and y-coordinate 3. Copy figure 1.4 and mark S and Q in your diagram. Mark any point P in quadrant 1 and any point R in quadrant 3 and write down their coordinates. Think and reflect. Question number 1. What is the x-coordinate of a point on the y-axis? Question number 2. Is there a similar generalization for a point on the x-axis? Question number 3. Does point Q, y, x ever coincide with point P, x, y? Justify your answer. Question number 4. If x is not equal to y, then x, y is not equal to y, x, and x, y is equal to y, x if and only if x is equal to y. Is this claim true? Exercise set 1.2. On a graph sheet, mark the x-axis and y-axis and the origin O. Mark points from -7, 0 to 13, 0 on the x-axis and from 0, -15 to 0, 12 on the y-axis. Use the scale 1 centimeter is equal to 1 unit. Using figure 1.5, answer the given questions. Here we have figure 1.5 in which we can find the x-axis and y-axis. On x-axis, we have the coordinates of x-axis marked as -6, -5, -4, -3, -2, -1, 0 with origin O, 0, 0, and +1, +2, +3, +4, +5, +6, +7, +8, +9, +10, +11, and +12. We have points marked as A, 12, 0 on this axis. We also have positions for point 8, that is D1, W2 at +7, W1 at +3, and point P at -6. We have position of point B at 12, 10 and position of C at 0, 10. The position of the room displayed is between O, A, B, C, and the bathroom is adjacent to this room with points 0, F, R, P. The showering area is marked between S, H, and W. The y-axis is in between the room and the bathroom with points marked as +1, +2, +3, +4, +5, +6, +7, +8, and +9. We have position of the bed marked as S1, S2, S3, S4, and position of the wardrobe as W1, W2, W3, W4. Page number 8. Question number 1. Place Rian's rectangular study table with 3 of its feet at the points 8, 9, 11, 9, and 11, 7. First, where will the 4th foot of the table be? Second, is this a good spot for the table? Third, what is the width of the table? The length. Can you make out the height of the table? Question number 2. If the bathroom door has a hinge at B1 and opens into the bedroom, will it hit the wardrobe? Are there any changes you would suggest if the door is made wider? Question number 3. Look at Rian's bathroom. First part. What are the coordinates of the 4 corners O, F, R, and P of the bathroom? Second, what is the shape of the showering area SHWR in Rian's bathroom? Write the coordinates of the 4 corners. Third, mark off a 3 feet by 2 feet space for the wash basin and a 2 feet by 3 feet space for the toilet. Write the coordinates of the corners of these spaces. Question number 4. Other rooms in the house. First one, Rian's room door leads from the dining room, which has the length 18 feet and width 15 feet. The length of the dining room extends from point P to point A. Sketch the dining room and mark the coordinates of its corners. Question number 2. Place a rectangular 5 feet by 3 feet dining table precisely in the center of the dining room. Write down the coordinates of the feet of the table. 1.4. Distance between 2 points in the 2D plane. We know how to find the distance between 2 points if they are on the axis or if they form a line segment parallel to the axis. For example, in figure 1.5, we can find the distances W1, W2 and S1, S2. What should we do if the segment joining the points is not parallel to either axis? We can use the Bodhaina-Pythagoras theorem, which you have studied in grade 8. We can use this result to find the distance between any two points in the xy plane. Page number 9. We can find a triangle ADM in figure 1.6. We are given a graph sheet on which we can find the markings on x-axis and y-axis. The points marked on x-axis are -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. On y-axis, we can locate the points 1, 2, 3, 4, 5 and 6. We also find a triangle AMD with coordinates as A 3, 4, M 9, 6 and D 7, 1. Triangle ADM is an acute angle triangle in the first quadrant. How do we find the lengths of its sides AD, DM and MA? Think and reflect. Question number 1. In moving from A 3, 4 to point D 7, 1, what distance has been covered along the x-axis? What about the distance along the y-axis? Question number 2. Can these distances help you find the distance AD? Figure 1.7 gives us a clue. The distance moved along the x-axis is given by CD. CD is equal to x coordinate of D minus x coordinate of A, that is equal to 7 minus 3 is equal to 4. The distance moved along the y-axis is given by AC. AC is equal to y coordinate of A minus y coordinate of D, that is equal to 4 minus 1 is equal to 3. Using the Bodhaina-Pythagoras theorem, we get the distance AD is equal to square root of 4 square plus 3 square, that is equal to 5 units. Page number 10. Here in figure 1.7, we have x-axis and y-axis both perpendicular to each other meeting at origin O, which is marked as 0. And on x-axis, we have the points 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. On y-axis, we have points 1, 2, 3, 4, 5 and 6. We can also find the points marked as A 3, 4, M 9, 6, D 7, 1. And we can locate point C here as 3, 1. We similarly find the distances DM and MA. DM is equal to square root of 2 square plus 5 square, that is equal to square root of 29 units. MA is equal to square root of 6 square plus 2 square, that is equal to square root of 40 units. In general, the distance between the points x1, y1 and x2, y2 is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square, and is calculated as depicted in figure 1.8. In this figure, we have position of points A, F and D. A is marked as x1, y1, D is marked as x2, y2, F is marked as x1, y2, and the distance between AF is marked as y2 minus y1, and distance between F and D is marked as x2 minus x1, and the distance marked on AD is written as square root of x2 minus x1 whole square plus y2 minus y1 whole square. Page number 11. It makes no difference whether x2 minus x1 and y2 minus y1 are positive or negative, as we are simply measuring the shifts along the two axes. What if x1, x2, y1, y2 take negative values? In figure 1.9, triangle AMD is reflected in the y-axis. What are the coordinates of the images of points A, M and D? Here we have figure 1.9, in which we can find the markings on the x-axis as -9, -8, -7, -6, -5, -4, -3, -2, -1, 0, and 1, 2, 3, 4, 5, 6, 7, 8 and 9. On y-axis, we have the markings as 1, 2, 3, 4, 5, 6. We have points marked for triangle AMD as A as 3, 4, M as 9, 6, D as 7, 1. Also, we find point C as 3, 1. We find the images of these points A, M, D along the y-axis reflected, and the points reading as A dash minus 3, 4, D dash as minus 7, 1, M dash as minus 9, 6, and C dash as minus 3, 1. C dash D dash is equal to x coordinate of A dash minus x coordinate of D dash, that is equal to minus 3 minus within brackets minus 7, that is equal to 4. A dash C dash is equal to y coordinate of A dash minus y coordinate of D dash, that is equal to 4 minus 1, that is equal to 3. Using the Bodhaina-Pythagoras theorem, we get AD is equal to square root of 4 square plus 3 square, that is equal to 5 units. You can similarly calculate both D dash M dash and M dash A dash. D dash M dash is equal to square root of minus 2 whole square plus 5 square, that is equal to square root of 29 units. M dash A dash is equal to square root of minus 6 whole square plus 2 square, that is equal to square root of 40 units. We notice that reflection has preserved the lengths of the sides of the triangles. Think and reflect. Question number 1. What has remained the same and what has changed with this reflection? Question number 2. Would these observations be the same if triangle ADM is reflected in the x-axis instead of the y-axis? Page number 12. End of chapter exercises. Question number 1. What are the x-coordinate and y-coordinate of the point of intersection of the two axes? Question number 2. Point W has x-coordinate equal to minus 5. Can you predict the coordinates of point H, which is on the line through W parallel to the y-axis? Which quadrants can H lie in? Question number 3. Consider the points R 3, 0, A 0, -2, M -5, -2 and P -5, 2. If they are joined in the same order, predict. First part, two sides of RAMP that are perpendicular to each other. Second part, one side of RAMP that is parallel to one of the axes. Part 3, two points that are mirror images of each other in one axis. Which axis will this be? Now plot the points and verify your predictions. Question number 4. Plot point Z 5, -6 on the Cartesian plane. Construct a right angle triangle IZN and find the lengths of the three sides. Comment. Answers may differ from person to person. Question number 5. What would a system of coordinates be like if we did not have negative numbers? Would this system allow us to locate all the points on a 2D plane? Question number 6. Are the points M -3, -4, A 0, 0 and G 6, 8 on the same straight line? Suggest a method to check this without plotting and joining the points. Question number 7. Use your method from problem 6 to check if the points are -5, -1, B -2, -5 and C 4, -12 are on the same straight line. Now plot both sets of points and check your answers. Question number 8. Using the origin as one vertex, plot the vertices of first part, a right-angled isosceles triangle. Second part, an isosceles triangle with one vertex in quadrant 3 and the other in quadrant 4. Question number 9. The following table displays the coordinates of points S, M and T. In each case, state whether M is the midpoint of segment ST. Justify your answer. Page number 13. Here we are provided with a tabular column which reflects the positions of the points S, M, T as -3, 0, 0, 0 and 3, 0 in the first row, 2, 3, 3, 4, 4, 5 in the second row, 0, 0, 0, 5, 0, -10 in the third row and -8, 7, 0, -2 and 6, -3 in the fourth row. You are expected to complete the blanks besides these. The questions are: is M the midpoint of ST? Yes or no? You are also expected to write down the reason for your answer beside these columns. When M is the midpoint of ST, can you find any connection between the coordinates of M, S and T? Question number 10. Use the connection you found to find the coordinates of B given that M -7, 1 is the midpoint of A 3, -4 and B x, y. Question number 11. Let P, Q be points of trisection of AB with P closer to A and Q closer to B. Using your knowledge of how to find the coordinates of the midpoint of a segment, How would you find the coordinates of P and Q? Do this for the case when the points are A 4, 7 and B 16, -2. Question number 12. Part 1. Given the points A 1, -8, B -4, 7 and C -7, -4, display that they lie on a circle K whose center is the origin O 0, 0. What is the radius of the circle K? Part 2. Given the points D -5, 6 and E 0, 9, check whether D and E lie within the circle, on the circle or outside the circle K. Question number 13. The midpoints of the sides of the triangle ABC are the points D, E and F. Given that the coordinates of D, E and F are 5, 1, 6, 5 and 0, 3 respectively. Find the coordinates of A, B and C. Question number 14. A city has two main roads which cross each other at the center of the city. These two roads are along the north-south NS direction and east-west EW direction. All the other streets of the city run parallel to these roads and are 200 meters apart. There are 10 streets in each direction. First part. Using 1 centimeter is equal to 200 meters, draw a model of the city in your notebook. Represent the roads, streets by single lines. Part 2. There are street intersections in the model. Each street intersection is formed by two streets, one running in the NS direction and another in the EW direction. Page number 14. Each street intersection is referred to in the following manner. If the second street running in the NS direction and fifth street in the EW direction meet at some crossing, then we call this street intersection 2, 5. Using this convention, find A. How many street intersections can be referred to as 4, 3? B. How many street intersections can be referred to as 3, 4? Question number 15. A computer graphics program displays images on a rectangular screen whose coordinate system has the origin at the bottom left corner. The screen is 800 pixels wide and 600 pixels high. A circular icon of radius 80 pixels is drawn with its center at the point A, 100, 150. Another circular icon of radius 100 pixels is drawn with its center at the point B, 250, 230. Determine Part 1. Whether any part of either circle lies outside the screen. Part 2. Whether the two circles intersect each other. Question number 16. Plot the points A 2, 1, B -1, 2, C -2, -1 and D 1, -2 in the coordinate plane. Is ABCD a square? Can you explain why? What is the area of this square? Chapter Summary. To locate the position of an object or a point in a plane, we require two perpendicular lines. One of them is horizontal and the other is vertical. The plane is called the Cartesian plane, the coordinate plane, or the xy plane, and the lines are called the coordinate axis. The horizontal line is called the x-axis and the vertical line is called the y-axis. The coordinate axis divide the plane into four parts called quadrants. The point of intersection of the axis is called the origin. The distance of a point from the y-axis is its x-coordinate, and the distance of the point from the x-axis is its y-coordinate. If x-coordinate of a point is x and the y-coordinate is y, then x, y are called the coordinates of the point. Page number 15. The coordinates of a point on the x-axis are of the form x, 0, and those of the points on the y-axis are of the form 0, y. The coordinates of the origin are 0, 0. The coordinates of a point are of the form plus, plus in the first quadrant, minus, plus in the second quadrant, minus, minus in the third quadrant, and plus, minus in the fourth quadrant. If x is equal to y, then xy is equal to yx. If x is not equal to y, then x, y is not equal to y, x. The distance between points x1, y and x2, y is the absolute value within bars x2 minus x1 of the difference between x1 and x2. The distance between points x, y1 and x, y2 is the absolute value within bars y2 minus y1 of the difference between y1 and y2. The distance between points x, y1 and x, y2 is the absolute value within bars y2 minus y1 of the difference between y1 and y2. By the Bodhaina-Pythagoras theorem, the distance between points x1, y1 and x2, y2 is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Chapter 1 ends here.
Ganit Manjari, Part 1. You were just listening to this audiobook, Textbook of Mathematics for Grade 9. Narration, Swarnlata Sharma. Sound recordist, Prasoon Kumar. Assistance in production, Soumya Malik. Directed and produced by Vimlesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.